Good afternoon, everyone. So, so we have today I will be teaching the module two, that is chapter four, operators. So, as you all seen in the chapter three, you have gone for concepts like data types, variables, and arrays. So now, apart from that, now we are left out with another two chapters. Chapter four, that is operators, and chapter five, that is branching and looping statements. So now you come under the operators. So operators are broadly classified into four types. So firstly, you are having arithmetic operators. Second one is bitwise operators. Third one, relational operators. Fourth one, logical operators. So apart from that, there are some special operators that will be discussed in this particular class. So first you come for the arithmetic operators. So under arithmetic operators, we are having basic types followed with derived types. So which are the basic types? What you are going to see, the basic types are addition, subtraction, multiplication, and division. So these are the basic types up to modulus. Okay. So from the basic types, how many you are having? The basic types are 5 in number: plus, minus, star, slash, percent. So apart from that, now you are having the derived types. Derived types are plus plus. So first one is plus plus. It is an increment operator derived from addition. Next we have all the assigned decrement operator, minus minus, derived from subtraction. Similarly, now we have assignment operators, that is plus equals, minus equals, star equals, slash equals, mod equals. So all these are called as assignment operators, and these are called these are the derived operators. So now we shall see each and every operators with in detail. So coming for the next, here are the following program to illustrate the simple basic arithmetic operators. So keep the first program is you are having the data of all the integer data types, whereas in the second program what you are having, it is the data of all the double data types. So first we take the class name. The class name is basic math, which contains a main function. As I've already told, the class name should be same as file name what you give. So class name here is basic math. So file name should be basicmath.java. So inside that you are having a printf statement, integer arithmetic. Now you are having declaration and initialization of all the variables, and finally we are printing. So after executing all these statements, you can check out the program by taking and executing. So first you will be having what is a value. A value 1 plus 1 is equal to 2. So first you will be getting a is equal to 2. Next b is equal to a star 3. That is 2 star 3. B value should be 6. Next c is equal to b by 4. What is b value? B value is equal to 6. 6 divided by 4. So you'll be getting something like 1 point something, but c 1 point something is of floating data type, but c will is of integer data type. That's why you'll be getting it as c is equal to 1. Next you come for d. So d is equal to c minus a. What is c value? C value is 1 minus what is the a value? A value is 2. So 1 minus 2 will result in a d value, that is minus 1. Next e is equal to minus of d. So as d value is minus 1, e is equal to minus of minus 1, it becomes 1. That will be the output. Similarly, you are taking the same thing, but the thing is you are making use of double data type. So double will come for floating. So floating data type. So what's the only one case what you did is everything will be done with fractional and decimal points. So now you come for the modulus operation. Modulus, as you all know, the division operation will have two operators. One is slash, the other one is percent. Slash gives you the quotient, whereas mod, that is percent, gives you the remainder of division operation. So here is a particular program. So first you have taken the class name as modulus with the main containing two variables, x of integer data type and y of double data type. So now modulus will always return what? It gives the remainder of the division. So now we are taking x value as 42, y value is equal to 42.2 25. So now you are modding the result x and y value with 10. So that gives x mod 10 is equal to 42 mod 10. That gives the result as remainder is 2, quotient is 4. As mod gives you the remainder, we now consider x mod 10 is equal to remainder is 2. So similarly go for y is equal to 42.25. So y mod 10 will also get you the value remainder 2.25. That will be the result. So next you come for the arithmetic compound assignment operator. So compound assignment operator is similar to shorthand operator. Shorthand assignment operator, as you are all know, shorthand assignment means, so you will be replacing on equal symbol on left as well as right. If the operand is same, then we replace that one with a shorthand operator. So best example is, as you all know, shorthand is used when you have left and right variable as same. So left of the assignment operator you are having a, on right of the assignment operator also you are having a. So that can be replaced as following statement: a plus is equal to 4. So that can be rewritten. This is called as a arithmetic operator, arithmetic assignment operator. So similarly, so plus equals is called compound assignment operator. Okay, so it performs the same action. They increase the value of a by 4. So here is another example. On assignment operator, on left you are having a, on right also you are having a, which can be expressed as a percent is equal to 2. The compound assignment operator provide two benefits. They save you a bit of typing because they are shorthand. Second, Second, they are implemented more efficiently by Java runtime than their equivalent long forms. So this is the following program that will be illustrated. So we are having a class called op equals with a main function. Int a equals 1, b equals 2, c, so many things. So declaration and initialization of a, b, c with values 1, 2, 3 are done here. Now we are going to increment a value, B, C, and C has done so many things. So first you will be getting A plus is equal to 5 is nothing but A is equal to A plus 5. So what's the A value you are having? 1. 1 plus 5. A value will be 6. Now you come for the B. B star equals 4 is nothing but B is equal to B star 4. So what is B? 2 star 4. So B value will contain 8. So output of the B will be 8. Next you come for C plus is equal to A star B. So what is the A value and what is the B value? Now you have to keep in your mind. After this addition and after these two expressions, so A will contain 6, B will contain A. So now you come for the C. C is equal to A contains how much? 6, and this one will contain 8. So 6 star 8, 48. 48 is to be added with C value. 48 plus 3 is equal to 51. So now we are modding C mod is equal to 6. That is C is equal to C mod 6. What is the C value? 51. 51 modded with 6. That will give you the remainder what you have, that will be the result. So which C will be printed? What the C value you are getting after the mod operation, that will be the result of the C. So next, inside that, after all the basic operations, now you come for the next topic, increment and decrement. So increment is an operator which increments the value by 1. So suppose if any variable is having a is a variable which containing a value 1, its increment is given as a will contain value 2. Similarly, decrement means decrease the value of a variable by 1. So suppose they take it as an example, x is equal to x plus 1. So that can be rewritten as x plus plus. Similarly, x is equal to x minus 1 is given as x minus minus. So now you come for the postfix form and prefix form. So suppose if you are getting an operator first, so operator that is plus plus first followed by an operand. So it is called as a prefix form. So here you consider y is equal to plus x. So here the operator is in first. So that's why we tell it as prefix form. But when you come for this one, x is equal to 42. So this is x plus plus is called as a postfix form, plus xs is called as a prefix form. So where the plus plus will come, that gives you the concept. If the operator is after the operand, that is called as a postfix. If the operator is before the operand, it is called as a prefix. So suppose you keep in your mind x is equal to 42, y is equal to plus 6. So what will be the output of x and y after this statement? So keep in your mind, as before x is incrementing, as we have two operators, one is equals, the other one is plus plus. So which operand should be evaluated first? So first it will be assignment operator will be evaluated first, and then the increment operator will be evaluated second. So assignment means it will be done to variable y, then increment will be done to variable x. So as we all know on the assignment, so increment will be done on the operand. So y is set to 43 because increment is occurs before x is assigned a value y. Thus you can tell that, so y value is equal to 43 before the x is incremented. So that's we tell x is equal to x plus 1 and y is equal to x. So y is equal to plus x is equal to x is equal to x plus 1 and y is equal to x. However, when you write like this, x is equal to 42, y is equal to 42, y is equal to x plus plus. Now we are assigning a value of x to y. Assign a value of x to y and then increment the value of x. So that's why after this statement, y will containing a value 42 and then the x will be incremented by 1, that is 43. So now we come for this particular program. So here we are taking a class IncDec. So under IncDec you are having, a main function with variables a equals 1, b equals 2, and c and d. What c, d, and c++ will contain, now we shall see. So as you know, c is equal to plus b. Here the c, what is the c value? Here b is incremented for the value of increment is done first and assigned to variable c. So what is the value of a? Value of a is what you are having, you have to keep that particular thing. So c is equal to plus b. So b is incremented, so b value will be given 3. Next, d is equal to a plus. So what will be the a value? D value will be 1 and a value will be 2. Similarly, C++. So C++ is nothing but, what is the C value you are having? So C value will be 3. As you increment, it will be gone on to 4. So you will be having a bit of clarification doubt in understanding this program. So listen carefully so that you can easily understand. So first inside this you have taken two variables A and B, and a is equals to 1 and b equals 2, and there is no operations for c and d. So c is equal to plus b you have given. So now what is the c value you will be having is, so increment will be done and assigned to c. So whose increment will be done? B's increment will be done. So c value will contain 2 and b value will contain 3. Okay, next you take d is equal to a plus plus. Now you assign a value a1 is assigned to d. The value a is assigned to d, and then and a is incremented. So now we tell what is c value. C value is equal to, you get it as, next, b is equal to 3, a is equal to 2, and next d is equal to 1, and c plus plus, as c will contains the value 3, it will be incremented, so you get a value 4, so that will be printed. So next you come, that completes the arithmetic operators. Come for the next class, that is bitwise operators. So bitwise Java defines several bitwise operators. Under that also there are basic types and some derived types. So which are the basic types? As you all know, for bitwise we will be having unary not, and, or, exclusive or, right shift, zero fill, and shift left. So these are the three basic things, and derived things are bitwise and assignment, or assignment, exclusive or. So what are all the concepts what you have discussed from bitwise and to shift left, everything you will be having a assignment operator. These are the derived types from this following basic types. Okay, so now we shall see each and everything in detail. So Java defines data types that can be applicable to all long, int, short, char, and byte. So so now we come for the bitwise logical operations. So under bitwise logical operations, you are having ampersand, pipeline, caret, and tilde. So keep in your mind, this is ampersand, this is pipeline, this is caret, and this is tilde. So first you get A, B, you are giving the values 0, 0, 0, 1, 1, 0, 1, 1. You can end it like this. First you will be getting 0, 0. Next you will get 0, 1. Next you will get 1, 0 followed with 1, 1. So A or B. Or is not, keep in your mind, or is nothing but addition. Ampersand and is nothing but multiplication. Okay, so when you go for addition, 0 plus 0 will give you 0, 1 plus 0 will give 1, 0 plus 1 you give 1, 1 plus 1 you get the value 1. Coming for ampersand, A ampersand B, 0 into 0, 0, 1 into 0, 0, 0 into 1, 0, 1 into 1, 1. Coming for, so next particular thing, it is X or XOR operation, exclusive OR operation. Under exclusive operation, keep in your mind, identical ones will be given value 0. So identical means if both are 0, value will be 0. If both are 1, the value will be 0. Okay, remaining and all, you will be having 1, 1 only. If there are same, there you will be assigning a value 0. But if you are having different numbers, you are assigning a value 1. So finally you come for the negation of an operand. Negation means it is a unary not operand which works only on one operand. So when you give value 0, you will get 1. When you give value 1, you will get 0. So that is the operation of negation. So next you come for the particular bitwise not. So bitwise inverts all of the bit. For example, you take the number 42, its bit binary pattern is given like this. So now we are going to reduce the, replace 0 by 1 and 1 by 0. So what you get, you will be getting 1, 1, 0, 1, 0, 1, 0, 1. So come for bitwise and. So bitwise and is nothing but what you have seen in the both operations. If both operands are also 1, produces a bit 1 if both operands are also 1. So keep in your mind the bitwise AND operation. So 0 AND operation it is. So you have to perform multiplication. 0 into 1, 0, 1 into 1, 1, 0 into 1, 0, 1 into 1, 1, 0 into 0, 0, 1 into 0, 0, 0 into 0, 0, 0 into 0, 0. So this is bitwise AND operation. Next you come for bitwise OR operation. OR means you have to perform an addition operation. So 0 plus 1, 1, 1 plus 1, 1, 0 plus 1, 1, 1 plus 1, 1, 0 plus 0, 0, 1 plus 0, 1, 0, 0, 0, 0, 0, 0. This is OR operation. Next, XOR operation. So bitwise XOR operation combines bits such that if exactly one operand is 1, the result is 1. ಸೊ XOR ಆಪರೇಷನ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ XOR if both are same, if both the numbers are same, give 0. If both are different, give the value 1. So that is XOR operation. So that is, so here you are having 0 1. 0 1 is considered as 0 1 is given as 1. So as you are having 1 1, both are identical, you are taking value 0, 0 1 1 1 1 0 0 0 0 1 0 1 0 0 0 0 0. That means if both are identical, you write 0. If both are not identical, you write 1. So following this the program what you will be having. So you have to type all these programs and you have to see. So you have taken the, I will be just examining what can be the error. Okay, so first you have BitLogic. So you are binary, so many strings are taken. So under the strings, first you are taking int a is equal to 3, that is 0 plus 2 plus 1. So 3 will be written as 0011. B is equal to 6, that is 0110. C is equal to A or B. So A equals A or B. So you'll be getting 1, 1, 1, 0. So C value will be 0, 1, 1, 0. D value will be 0, 0, 1, 0. A X or E value will be, so E value will be 0, 1, 0, 1. So similarly you do and see the output what you will be getting. Okay, so next I will move to the left shift operator. So left shift operator shifts all of the bits in a value to the left a specified number of times. It is a general form value then num. That means value is a variable that move to be left shifted by n number of times, that you are giving it as, num. Num specify number of positions to left shift the value in a value. It moves all of the bits in specified value to the left by number of bit positions specified. So this is the right shift operator. So right shift operator, you are having shifts all of the bits in a value to a right a specified number of times, value right shifted by num. So this is an example that can be easily solved. As you are all know, the right shift means shift represent that in binary and shift the bits one by one. So unsigned right shift operator, as you all automatically shifts higher bit with previous contents, higher order ಅಲ್ಲಿ ಇರೋ ಬಿಟ್ಸ್ ಅನ್ನ ರೈಟ್ ಅಲ್ಲಿ ಲೆಫ್ಟ್ ಅಲ್ಲಿ ಶಿಫ್ಟ್ ಮಾಡೋದಾದ್ರೆ ಲೆಫ್ಟ್ ಮತ್ತೆ ರೈಟ್ ಶಿಫ್ಟ್ ಅಂತ ಕರಿತೀವಿ. ಇಫ್ ಯು ಆರ್ ಶಿಫ್ಟಿಂಗ್ ಸಮಥಿಂಗ್ ಡಸ್ ನಾಟ್ ರೆಪ್ರೆಸೆಂಟ್ ಎ ನ್ಯೂಮರಿಕ್ ವ್ಯಾಲ್ಯೂ, ಯು ಮೇ ವಾಂಟ್ sign extension to take place. So this is known as unsigned shift. So accomplish this, you will use Java unsigned, that is shift right operator. So right shift you will be getting only 2, but shift right operator you will be getting 3. So that always shift zeros into higher order bits, zeros into higher order bits. So here is an example. Here you have a value a is equal to -1. This -1 is to be shifted shift right by 24 times. The same operation when you carry out, it will be given like this particular thing. So next you come for the, so bitwise operator compound assignment. Bitwise operator, that is compound assignments. So all of the binary bitwise operator have a common form similar to that of algebraic, which combines assignment. So you can write it as a right shifted by 4 times can be written as a right shift operator double equals 4. So similarly, you can carry out all the assignment operators for R, X, or X, or everything by giving that the concept a is equal to a or b can be given as a or is equal to b. This is a bitwise operator compound assignment. Next you come for relational operator. Relational operator determine the relationship that one, so relational operator is a third type. So first we have seen arithmetic, second you have seen bitwise, third is the relational operators. So relational operator, how you have come across, you will be familiar with these things. So relation, it will be checking, and it will, output of the relational operator will result in a Boolean value, that is true or false. So you are having so many operands, double equals, equal to, not equals, greater than, lesser than, greater than or equal to, lesser than, equal to. The output is a Boolean value. If int a is equal to 1, b is equal, a equals 4, b equals 1, Boolean c is equal to a less than b. So when you perform, substitute the values for a and b, 4 less than 1. What is the condition? So condition 4 is less than 1, condition is false. So Boolean C will contains a value false. So that is the relational operators. So next you come for the logical operators. So coming for Boolean logical operators, so it is the last category you will be having apart from special operators. So this is the fourth one, Boolean logical. So it's operate only on Boolean operands. So it results in a two Boolean values, true and false. So here also some of the operands are there, which are basic things and derived operators. So basic operators are logical ampersand, logical or, logical XOR, and these are the logical things. Next you will get short circuit or, short circuit and, logical not. Next you perform arithmetic assignment operations, and assignment, or assignment, XOR assignment. Then you will get equal to, not equal to, ternary. These are the three things. Everything you will be very familiar with, but you should be familiar with these two concepts, short circuit assignment operator. So this one you are not familiar with, and that will be discussed in detail here. So Boolean values will be performed in the following table. So first you will be getting not operator. So not operator means if not of, you will be having two Boolean values. Not of true is equal to false, and not of false is equal to true. So here it will be in these terms, rather than using true, false, false, true. You can take it as true, 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 false, false, true, and false, false. So A or B. So it is similar. You will be having the same type of values what you are getting in bitwise also. But keep in your mind, true will be given the value 1 and false will be given the value 0. So the everything's remains same here also. So but in place of true, in place of 1 you are having a true, in place of 0 you are having false. That is the only change compared to bitwise and logical. So now you come for the very important exam point of view topic. I have mentioned here very important also. So it is short circuit logical operator. Java provides two interesting Boolean operators not found in any computer language. They are short circuit logical operator. So as you all know, understand this particular 2 points that will give you the idea. So OR operator results in true when A is true, no matter what B is. Similarly, AND result in false when A is false, no matter what B is. If you use logical OR and AND forms rather than bitwise OR and AND forms, Java will not bother to evaluate the right hand operator. Then the outcome can be determined by the left operator alone. So this is very useful when the right hand operand depends on the value of the left one. Right hand operand, so keep in your mind, when the right hand operand depends on the value of left one in order to function properly. So for example, you are giving this particular thing. If denom not equal to 0, double ampersand num by denom greater than 10. Since the short circuit form of AND is used, there is no risk of causing a runtime expression when denom is 0. If this line of code is executing using single ampersand, both sides will be evaluated. So now we can also check that when denom not equal to 0, first you will be evaluating this part. Then next you will be evaluating num by this part. So this is the leftmost operator part, and this one is considered as rightmost part. So that is a double ampersand b. If num denom not equal to 0, that means condition is true. Num by denom greater than 10, that condition is false. So true and false will result in false only, because it is a AND operator. True is 1, false is 0. 1 into 0 will give the value 0. So that's why we take it as denom is equal to 0. So that is the one particular example. So next you come for the next topic, assignment operator. So assignment operator is a single equal sign, that is equals. It works in Java as much it does in C and C++ also. So assignment operator, on left you should have a variable, on right you should have a value. Example is a is equal to 1. So a is a variable and 1 is the expression. And variable should also belong to the data type of the value what you are giving. Suppose you give a is equal to value 1. So a should be declared with a data type int. So assignment operator does have one interesting attribute that you may not be familiar. So int x comma y comma z, declaring of three variables x, y, z. Now we initialize each and every value of all the variables to the value 100 by giving x is equal to, y is equal to, z is equal to 100. So sets the value x and y, x comma y and z to the 100 using a single statement. So first initially assignment operator, the value 100 is assigned to z. Next the value of z is assigned to y. Next value of y is assigned to x. So that is the assignment operator. So chain assignment operator. Next you will be having the special operators. So under special operator only you are getting all this. One is assignment. Next one is question mark. Next is parenthesis. So after parenthesis, you'll be having one program and this will end. So after assignment operator, now you have the question mark. It is a ternary operator. So as you all know, ternary operator means you'll be having three operators there. So one is question mark. So expression 2 colon expression 3. So here expression 1 can be any expression which evaluates to a Boolean value. If expression 1 is evaluated to true, then expression 2 will be displayed. So if expression 1 is evaluated to false, then expression 3 is evaluated. So keep in your mind the following example. So under following example, you are having ratio is equal to denom double equals 0. So first expression, what your expression is, denom double equals 0 is the expression 1. Next expression 2 is 0 and expression 3 is num by denom. So what the result what you are getting for the entire will be assigned to the variable called ratio. So when Java evaluates this assignment expression, it looks for the left of the question mark. So what is the left of the question mark is the expression 1. If denom equals 0, then expression, if denom equals 0, then the expression 2, that is 0, will be stored in the variable ratio. Similarly, when denom not equal to 0, then you are getting num by denom operation will be done and the resultant value will be stored into the ratio. So, so that will be the result will be produced by question mark operator, which is then assigned to ratio using parenthesis. So parenthesis, the last part of the special operator you are going to discuss. It raises the precedence of the operations that are inside. So suppose best example of understanding parenthesis means inside an expression, if you contain more number of operators, so then you may get to go for a confusion that which operator to be evaluated first. At that time, you can make use of parenthesis concept. So under parenthesis concept means, as you see the example, A right shifted by B plus 3. So here you are having two operators. One is right shift operator, the other one is plus. So which one is to be evaluated? So it leads to the confusion of which to be evaluated. So first, initially, if this is the expression, it first adds 3 to b, 3 to b, as each and every expression you will be evaluating from right to left. So first 3 to b is to be added, and then shift the result by that result. Shift the a by that result. Suppose b contains a value 1. So 1 plus 3 is equal to 4. Now a is right shifted by how many times? 4 times. So suppose if you want to shift first the right shift, followed then by adding the value 3, then you can have a parenthesis for right shift operation, that is a right shifted by b. So that will give you the result. So first, the operations operators will be given the higher precedence for parenthesis. So precedence rules are should also be discussed, as we all seen in C and C++. First precedence will be evaluated, and then the logical, then bitwise, and finally the arithmetic operation. So that is the concept what you have using parenthesis. So if it leads to the confusion, so in order to avoid the confusion of which operator to be evaluated first, we are making use of parenthesis. So parenthesized operator will be evaluated first, followed by unparenthesized operator. So here is the following program. So this program will perform all the Boolean logic expressions. So first you have a class name called BoolLogic, which contains a main. You are giving a value of a equals true, b equals false, c is equal to, you are giving so many statements on executing. First, what is a value? A value is equal to true. Next, what is a b value? B value is equal to false. Next, come for c value. True or false. True it can be, this is the single bitwise or operator. So true is taken as 1, and false is taken as 0. So 1 plus 0 will result in 1 only. So C will be true. So A or B, you have taken it as A or B is equal to true. Next, D is equal to A and B. So A and B means for true into false, 1 into 0. So 1 into 0 will always give you 0 only, that is false. Next, XOR. A XORed with B. So true into false. True, both are same means it will be false. If both are different means it will be true. So A or B is equal to true. So similarly, not of A, as A is true, not of A is false. So this one you check, and that output should also be true. So this is the concept what you are having. So that is Java. So that is Java, that is Java operators. It is the chapter number 4. So after that, next you will be having a chapter number 5, that is control statement. It is bit lengthier. So this chapter you look after and discuss if you are getting any other doubts. So here I will be ending this particular video, that is module 2, chapter number 4, operators. So if you have any doubts, feel free to contact me. Thank you.